Hey guys, in this video we are talking about the law of conservation of energy. And it's kind of like the law of conservation of momentum, which I did in an earlier video, but it just says that energy is neither created nor destroyed. It's just transferred from potential energy to kinetic energy, or from kinetic energy to potential energy. So the first step I would do, if I saw a question, is I would just say the energy you have before something happens is equal to the energy you have after. Now, for some reason, I don't like using B and A down there. I have no idea why. I would rather say the energy you have initially is the same as the energy you have final. Final energy equals initial energy. So we're going to do an example, and it says, a stone is dropped from a height of 12 meters. What is the speed when the stone hits the ground? Well, let's think about what kind of force is acting on this free-falling object. It's going to be gravity. So the acceleration is going to be due to gravity, which is going to be 9.8 meters per second squared. So let's think about it. You have a stone up here. At this point, all it has is potential energy. It's not moving, it's just hanging up there because you're holding it. When the stone drops, it loses all that potential energy because it approaches being on the surface of the earth, and it gains kinetic energy. It's moving. So all of its potential energy is being transferred into kinetic energy. The energy it has before, or the energy it has initially, is potential energy, and the energy it has after, or final energy, is all kinetic energy. So potential energy is described as mass times the force of gravity times the height, and kinetic energy is always described as equal to 1/2 the mass times the velocity squared. So what's really interesting about these formulas is that it didn't matter how much mass our stone had, because the mass it has before will cancel out with the mass it has after. So it's irrelevant whether this stone is 1 kilogram or 1,000 kilograms. We have G, the force of gravity, which is 9.8 meters per second squared. We know our stone is dropped from a height of 12 meters. And did I tell you we were asked what speed does it hit the ground? So that's going to be velocity is what we're solving for. So 9.8 times 12, I got that to 117.6, so that's going to equal 1/2 the velocity squared. Okay, so all I'll do is multiply by 2 on both sides, because 1/2 times 2 will just be equal to 1 velocity squared. 2 times 117.6 I get is 235.2, and that equals velocity squared. To get velocity, all you need to do is square root both sides, and the square root of 235.2 is 15.3. Think about your units. It's going to be meters per second. We're going to do another example. This time we're going to do something. It's not free falling, it's a box that's sliding down a sort of frictionless inclined plane, or a ramp. So I'll draw you a little picture. We've got sort of a wedge type shape like that, and like some mass on it, and it's sliding down. The angle of our ramp compared to like the surface of the earth, or a flat surface, is 29 degrees, and the length of the ramp is 11 meters. And we're told the box slides down a frictionless ramp starting from rest. Find the speed when it hits the bottom. Well, okay, energy before, when the box is up here, it's got all potential energy. It's not moving, it has the potential to slide down if we were to let go and stop holding it. So the energy before is energy potential, and energy potential is equal to mgh. And when the box gets down here, it's on the surface of the Earth, so it doesn't have any potential energy anymore. If we were to drop it, it's not like it would fall anywhere. And it's moving by now, so we have some kinetic energy. Kinetic energy is 1/2 mv squared. Again, the mass of the box is irrelevant because we have mass on both sides of the equal sign, so they'll just end up canceling each other out anyway. Now, we need to figure out what is the height. We know gravity is going to be 9.8. The height, we can use our triangle and some knowledge of trigonometry to solve. So this side over here is going to be the height, and we're given an angle. If this is a right angle triangle, then this side, the 11 meters, is going to be the hypotenuse. So with respect to this angle, it looks to me like that side's going to be opposite. So the formula that uses opposite and hypotenuse is sine. So we'll go sine of 29 degrees is opposite, and let's just call that variable x for right now, over hypotenuse was 11. So all you need to do is, on your calculator, make sure it's in degree mode, type in sine 29, and I got it equal to that decimal, and then just multiply by 11, and I get that height is equal to about 5.3 meters. So I just need to plug that in for height down here. 5.3 equals 1/2 velocity squared. 9.8 times 5.3 is equal to 51.94. To get rid of the half, I'll multiply by 2 on both sides. 51.94 times 2 is 103.88. And we have velocity squared, so square root it to get velocity. And when I take the square root of 103.88, that's approximately equal to like about 10.2 meters per second.